Good evening all. Today I will show you how you can connect your contactor coil with the appropriate voltage required for the coil. We have the single phase and the three-phase contactors here with us presently, and we have different connection for both single phase and the three-phase. For the single phase, it is four contacts, four contact terminals. You have the live and the neutral input and the live and neutral output. The live and neutral input will come from your power supply, and the live and neutral output goes to the equipment you want to power, single phase equipment. This is used for the compressor for AC refrigeration, also for other equipment if you want to supply to motor, electric motors and all that. Now for the coil, the specification of the voltage required for the coil is always stated at the plate. You can see for the single phase contactor, you can see the coil voltage 190 to 220 volts. This is for this particular contactor coil. When you supply 190 to 220, you will have the proper functionality of this contactor. Let me show you an example of what I mean. We will connect 220 volts to the contactor coil, and we see the behavior of the contactor. You can see with me the appropriate voltage required for the coil is 220 volts. When you supply for the coil, this is the coil. You supply the input voltage for the coil 220 volts. When you power, then the magnetic field will be generated for the contact to be made. Also, this is same applicable for the three-phase system. For every contactor you see, it is very, very important for you to identify the coil voltage. The coil voltage is always stated at the plate of the contactor. You can check the information from here. This is three-phase. You can see this is three-phase contactor, and the coil voltage is stated here, 24 volts. If you supply 240 at this coil, you can damage the coil. As a very good technician, you have to identify the voltage required to power your contactor. For this voltage, we don't have. We have this contactor. This is three-phase contactor system. You also identify that this is 220. You can see from here. 220 volts stated in the A1 and A2. For this type of contactor, you don't need to worry yourself, you don't need to bother about where the live and the neutral of the coil is, because the live and neutral of the coil is identified by A1 and A2, wherever the position is. If live and neutral A1 and A2 is on the opposite side, no problem. Connect at the opposite side. Let me show you what I mean. This is A2. This is A2. This is terminal A2. And this is terminal A1 on the opposite side. I will connect. This is three-phase contactor. We have connected to terminal A2 and terminal A1, no matter the position. Then let us see the behavior of the contactor. Watch me closely. You can see what happens when you power the contactor coil. You will see that the contactor is linked. You can see, for example, this is. This is what happens in the contactor. Take a look at this. You have line L1, line L2, line L3. This is the input power supply for the contactor. In case you have three-phase power supply, you have three-phase machine, three-phase motor, you want to connect with the contactor, it is very simple. Let me show you what happens inside the contactor. Take a look at this. Line L1 is linked with line T1. Line L2 is linked with line T2. Line L3 is linked with line T3. This is achieved when the contactor coil is pulled down. The magnetic field is generated and the switch pulls down the contactor to connect this together. And when they are connected together, the appropriate voltage you have put in the input goes to the output, supplying the motor you have, supplying the machine you want to connect, and whatever you have. So for this, also this coil voltage, it is 240, 220, 240. This is for A1 and A2. For every contactor, you have to identify the coil voltage. And the coil voltage is stated by the side, just by the side under the coil, before the coil. You have to see this. This is same for other three-phase contactor. We have live neutral, we have three-phase and NO neutral. So you have 1, 2, and 3 linked together with T1, T2, T3 inside. They will only be linked when there is magnetic field to pull down the contact point. Let us do for this one. This is three-phase contactor. You can see the information stated. You can see the diagram. Yes, you can see everything. Also for the coil, see the information for the coil. 220 to 240 60 Hz. This is the coil voltage. If I have to supply, for example, for this, A1 and A2. A1 and A2. Don't forget. Let us see the behavior of the contactor when we power the coil with the appropriate voltage. This is the voltage that is required to pull down this contact point and create the passage of the flow of current across the terminals. If you don't supply the appropriate voltage, you cannot generate the EMF required to pull down this contact point. You can see with me what happens. Okay? Very simple for you to understand. You can also have other contactors. Any contactor. This is 220. If you have any contactor, only put the appropriate voltage required for this contactor, magnetic field, to be generated, and you have achievement of the contactor. Okay, thank you for watching, and I will always come back here to give you all that you need in electrical technology. Always subscribe to our YouTube channel, like and share. Thank you.